end of module review, just so that you understand, so our students can practice and review at home and also see the work as it's done. So Sam works at a candy shop. A new shipment of candy just arrived. The total weight of his 4 boxes of candy is shown below on the scale. On a number line, round the total weight to the nearest 100 kilograms. Okay, so his weight is right here. We had to look to the side. It's below on the scale. So our number line is actually a vertical number line. We have 3 points that we want to always make. Our number is 103. And so we can even talk about how many hundreds, tens, ones we have. How many hundreds do we have? We have 1. So the bottom number is always going to be that. It was 100. Okay? Then another 100, because we're rounding to the nearest 100, so 100 and the next 100 would be 200. Our midpoint is halfway in the middle. So this is labeling our number line so that we can round visually. Then we have to label our number that we have, 103 kilograms. So we have 100, and I can even go 1, 2, 3. It's actually probably smaller than that, but just so we can see. So this is 103 kilograms. And as you can see, it is closest to the 100 on our number line. So our answer would be 100 kilograms. Okay. I'm going to scoot it up, maybe. All right. Each box is filled with smaller bags of candy. Sam compares bags of chocolate to bags of gumballs. The chocolate weighs 498 grams, and the gumballs weigh 341 grams. What is the difference between the weight of the chocolate and gumballs? When we're doing difference, we're doing subtraction. This process of circling numbers plus the unit and then boxing in words is something we do all the time so that they can decompose a word problem so that it doesn't feel overwhelming. So we're going to be subtracting 498 minus 341. These are grams. Students may be able to do this in their head. If they are not able to, if they struggle with that, you can draw this little line. It's like our reminder, oh, we're going to draw it over here on our place value chart. This is not mandatory, but it is helpful in understanding. So we have 4 hundreds and 9 tens and 8 ones. We're going to take away 1 1. That leaves 7. We're going to take away 4 tens. That leaves 5. And we're going to take away 3 hundreds. And that leaves 1. So as you can see, this is just the visual of what we're doing over here. We didn't even have to borrow or decompose a number. Like I said, students may be able to do this in their head or using their fingers, and that's fine. Whatever process is best for them. All right, our next problem. The clock below shows what time it is now. So the time now, we could go ahead and write. Oh, look, that says it is 3:22. Okay. Estimate the time to the nearest 10 minutes. So we are estimating. So we're going to take this minutes, and we could go 10 minutes. We could even draw our line. Okay, so we know we have 2 tens. So 2 tens is the same as 20. The next one up is 3 tens. That's the same as 30. And the middle would be 25. 22 is our number. That is right here. So if we're going to round or down, we're going to go down to 20. So we're rounding the time to 3:20. We don't know if that's PM or AM in this problem. Oops. All right, the next clock below shows the time that Sam gets to leave for work. Estimate the time to the nearest 10 minutes. So again, we have the clock is not yet to the 4. It's almost to the 4, but that means we're still in the 3 hour. And we're at 55, 6, 7, it looks like 57. Okay, so we're going to estimate to the nearest 10 minutes again. So since we have, this is our time, we have a 50 or 5 tens. That's what goes at the bottom of our number line. 5 tens, that's the same as 50. The next one up would be 6 tens, the same as 60. In the middle, we would have 55. And we are at 57. If we're rounding, this number would go up to the next 10. Now, our next 10 is 60. So time-wise, it would not be 3:60. This is when our time changes and our clock becomes 4 o'clock. We do know that, yes, 60 minutes is the time, but once that gets all the way up, it's going to be at 4 o'clock. It says, use your answers in part A and part B to estimate, we're estimating again, how long he has before he has to leave for work. So in the top part A, we had 3:20, and part B, we have 4. So we're going to take our 60 minutes and our 20 minutes, and we're going to subtract to see how much time he has left. He has 40 minutes left. Can you see? Oops. About 40 minutes. Let me put that about, because this is not exact. These are estimates. Okay. Okay, on the last one, the last page, we have the candy shop uses about 146 liters of syrup to make candy each day. Round to the nearest 10 liters to estimate how many liters of syrup get used each day. So what I'm going to do is I'm going to write that number, 146, and we're going to write hundreds, tens, ones. So that way we can even look and see, okay, we have 1 100, 4 tens, and 6 ones. We are trying to round to the nearest 10, that's here. We need to look at that number. So these numbers, if we even take that off the 100, we could say, oh, instead of 100, we could say, oh, I have 14 tens, 6 ones. It's the same number. So on my number line, I can put that. At the bottom, I can say 14 tens, and that's the same as 140. And then it's easy to just say one more, 15 tens. To make it the same, it's 150. The midpoint is where our students are struggling the most, but 140, 150, what's in the middle is 145. And these are all liters. I don't want to confuse with too many labels right now. So we know these 3 numbers right now, but we want to plot 146. We have 145. Right above it will be 146. If I round to the nearest 10, I'm going to go up to 150. 150. They use about 150 liters of syrup every day. It says use your estimate to find about how many liters of syrup are used every 2 days. So we have this is about for 1 day, so 150 liters plus 150 liters because 1 day, 2 days. That's a pretty simple one. I'll let you work on that. Calculate precisely how many liters of syrup are used every 2 days. So we want to know the exact. How many are used every 2 days? So we actually need to go back up. The number that we had on part A was 146. So on part C, we're going to write 146 liters plus 146 liters because this is the exact, this is our estimate. Let me make sure, estimate. So down here, of course, if we're adding 6 plus 6, that's 12. Put your ones down and carry your 10. Okay, and these are liters. I did not solve up here because I was hoping to let you guys do that. There's my solving for there. On part D, it says draw a tape diagram to find the difference between your estimate and precise calculation. So we want to find the difference, that's a subtraction, between part B and part C. We have 300. I have cords in the way, excuse me. So a tape diagram, when we're subtracting 300 liters. Is that correct? So this is our estimate. I'm labeling it. And here's our actual. Actual is 292 liters. This little part right here is our unknown. That is the difference between them. So after I show the tape diagram to show the difference, I'm able to subtract. There are zeros to go across. It's really good for us to draw it out just to see, visualize what we're doing. So I have 300s. That's all I have. That's all I can draw. But I need to take away 2 ones and 9 tens. So what I do is I break down this 100 to 10 tens, and I have to break down a 10 to 10 ones. Okay, so to mirror what I've done over here, I now have 2 hundreds. I now have 9 tens, and I now have 10 ones. It's the same number, just written in a different way. And we're going to take away 2 ones. That's 8 left. And we're going to take away 9 tens and 2 100s. These are placeholders, so our actual answer is just 8 liters difference. Parents, if you have any questions, you can email me. Let's be studying this for the next couple days. Thank you.